Hello everybody, Chaz Large here with another Fix It video for you. A slightly different beginning this time. I'd just like to show you my newly reorganised workshop. So let me just switch to the other camera. Can I? Now some of you may remember that my bench used to be over this wall with all my electrical bits and pieces over there. But I've now got rid of my ghastly garage door and had walls built in, brickwork on the outside, wood on the inside, and I've now moved my workbench so that it is now facing the window, so I've got natural daylight coming in there. Gives me a good chance to work on things in natural light. So much better. A lot more space on the floor in between. New racking there for bits and pieces, and more racking there, and I've still got stuff that needs to go up on some of these shelves, and a lot of stuff needs to be sorted out. So hopefully we will get on with doing a new video, and I've got several projects on the go, but this little one here is what I'm going to be working on at the moment. This is an old Philips monochrome TV, which I'm hoping to convert into a CCTV monitor, because I've got a TV up there that I use let me just show you up there. Let's just tilt up there. You can see that's my TV monitor that I use for computer repairs or the old analog inputs, videos and so on. But I also want to have this put somewhere so I can have my CCTV on all the time rather than having to keep switching that one. And this is a lovely little old black and white TV that I picked up off eBay for next to nothing. And I've just spent ages sort of getting it to a condition that it actually fires up and works, so I can actually hopefully move forward with modifying it for a video input. But I mean, when it arrived, the chassis was smashed, the tube was loose, the PCB was all broken, so I've spent ages working on that. I thought I'd get all that going first before I have the potential of showing the rest of the video. So that's what we'll do. We'll move on from there. So I'll just tidy things up a little bit and we'll get started. Right, so as I said in the intro, this is a black and white Philips television. It's a model number, there's a little label that came off. It's a 12B711, uses the TX chassis, and I chose this basically because it was cheap, black and white. I don't really need colour for CCTV monitoring. It's got just purely RF input. There are no external inputs to it at all. Other than the aerial. But the beauty of this is, if we have a look at the circuit diagram, is that it is an isolated supply. So there we have the mains input comes in and goes directly to this mains transformer here, and then that's on all the time. So the only thing about this is it's going to consume electricity even when you switch it off. So it's not exactly the most economical TV, but then I'm going to be able to be switching it on and off at the socket anyway. So if we go back to the circuit, we can see that the mains comes in, and we've also got 12-volt supply. Anyway, very simple regulator input for the power supplies. But the beauty of it is, being a monochrome TV, we're only worried about a video signal coming in. And if I just zoom out again on this for a minute to show you the whole of the video path, you've got the TV aerial, etc., coming in here, this video signal processing through here, the TV reception signal comes in there, and we've got a takeoff at this point for the audio, which we're not worried about, but the video comes to this transistor here, which is a TS350. And from the emitter of that, the video goes off to the video output stage to drive the tube, but it also comes down here into this circuitry, which does the synchronization signals for the line and field time bases. So if we were to look at the video signal that is going into the base of this transistor, we should see something like this waveform that's coming off the emitter with our test signal on it, and we should be able to break into that link there between that resistor and coil combination into the base and inject a video signal into there, and that's where we're going to be putting our CCTV or other video input into that. So that's what we need to do. We need to identify TS350, find out where it is, and see if we can work the circuit around that. Let's just get into it. So the first thing we need to do, obviously you can see that it is working. I've got my test card generator on RF feeding into this at the moment, so we'll turn it off, but remember that the mains is permanently connected to that transformer, so we need to switch it off and unplug it from the socket. So we take the RF out. Now, as I said, I did have to do a major repair work on this when I got it. The bottom part of the plastic chassis that supports the tube, that was all broken, so I managed to glue and super glue and hot melt glue that all back together, so it's pretty solid. The PCB across the front was also severely damaged, so I've had to do a lot of repair work on that, which you might see in this. So I'm just pulling off the control knobs because the circuit board won't come out with the knobs still in place. Put them in a little tray. So we should be able to get this into a position, and we should be able to get the circuit board out, and we should be able to turn the circuit board up to a position where we can see it with the camera. Okay, now the one thing I haven't sorted out quite yet in this new workshop is the lighting. So I've got one light that needs to be moved across. I just haven't got round to that yet. I had a fall on Saturday and severely hurt my back, so climbing up a ladder is not on my high importance, so you'll just have to bear with me that I'm pointing to the correct bits. So we're looking for TS350. Luckily on this printed circuit board, if I can zoom in on this a little bit to show you, luckily on this circuit board, Philips were very kind. They printed all the transistor details. So we've got TS312, TS111. So we want TS350, which I think is going to be round about this vertical sync, horizontal sync. The other thing is, I don't know if you've ever noticed on some of these, they've got like a grid pattern on. So you've got column A, B and C and rows 1, 2, 3, 4 and 5. So if I look in the service manual, it should tell me what the location is, that transistor. If I can find it, but I'm going to be lazy and just keep looking for it. TS5, TS3, so if it's a 3, it's probably going to be around here somewhere, because that's TS380, 410, typical. I bet I'm going to have to look it up.
Flippin' heck!
TS350, just found it, just down here. There it is. You can see all the work that I had to do because this board was basically smashed. So I've had to do a lot of repair work on the board, and glue and stuff to try and hold it all together. So TS350, 350, yeah. So collector base emitter. Just double check that on this side. TS350, yeah, definitely. So that's the one that we're interested in. So what we need to do is to just double check what the waveform is we're getting with the scope. So bear with me a second while I get the scope up and running. Right, I've got the scope set up. Still haven't worked out exactly where everything's going to go in this new layout of the workshop, but we'll get there eventually. Right, so we're going to put the scope on there. So if we now go on the base of this transistor, which we think is there, we should be getting our waveform, our video waveform. So we've got a fairly good waveform there. Let's just switch this to the standard colour bars, like so, and turn the circle off. So we should see a relatively good waveform on there, on the base, and then on the emitter. Yep. So it's obviously not. It's the triggering on it is automatic. Probably the amplitude needs to go up a little bit. Let's go give a better triggering. There we are. So let's just go back on the base, because it's the base that we want to go into. So what we need to do is to break into the base, so we need to find where the circuit is for that to do it. So let me just do a little bit of a close-up work on there to find where that is, but I'm going to power it down temporarily for the purpose of handling. Now that we've got I've got it into a position where I could see this transistor, what I discovered, that this is the base, that there was a blob of solder across these two little bits of print, which look like it may well be a factory test connection of some kind. That's just in normal mode, that's connected, but with that disconnected, let's just quickly get it back on. So let's just turn this set back on, put a RF signal in as before. Put it that way. Let's just see what we get there now. So we've now just got a blank white raster. So obviously that we've lost the video signal at that point. So let's try putting our connection to it with a piece of cable with a capacitor as an insulator, and inject video signal straight into it and see what we get. Right, I've connected a 100 microfarad capacitor to the base of that transistor. Now I've got this, I've got my scope signal, which I'll just double check that we're actually getting a composite video signal there. That's coming from my test generator. So we should be able to now see if we connect this ground to there, if we can get it to stay clipped. This is just a little test lead that I use for temporary things, and we clip that onto there. Hopefully it will stay, and we have got video, and it's a little bit OTT, so I think we've probably got too much video coming out of the signal generator, or maybe not enough, one or the other. It worked for a minute or two. Perhaps the automatic gain of the TV turned it down, so let's put that back to where it should be. Alright, let's put the scope on it and see what's happening. The signal is there. That's volume. I don't know why I'm twiddling the volume. That's brightness. That's contrast. How weird. It worked for a minute or two. What have we got on the other side of the capacitor? We've got a video signal on the other side of the capacitor. We've got nothing coming out of the emitter though. Have we overdriven this transistor somehow? Let's just resolder that link for a minute. The trials and tribulations of doing things like this, eh? Right, we're definitely switched off mains wise. Let's take that capacitor out. Because where I've worked on video signals before and done this, a 100 microfarad capacitor does the job quite adequately. Oh, I can't get at it. Just blob that blob across. If we can. Come on, blob. Oh, goodness. Can't blob it across. I'll just use the capacitor leg for a minute. Alright. Let's just switch it back on, see if we've still got, yeah, we've still got a proper picture. And the contrast works, and the brightness works. Okay, let's turn that off again. Take the blob off. Put that onto the base of that transistor again. And this time I'll disconnect my modulator, so we're only feeding composite video, and I'll turn the video down. And we'll put the scope on as well. So video is on, and we are 104 volts, 140 millivolts peak to peak, and we're on times 10, so that's 1.4 volts peak to peak, which should be enough. So if we drop that down, 2 volts is usually enough. That should be good enough. So it may be just we overwhelmed it. Let's see. Go on the emitter of that transistor. We're getting nothing. So let's turn that video signal up. That's a much more stable static. Let's put it on test card, so we can see sort of some sort of lines and things on it. Let's turn the video signal right up. Right. Should be about right there. That's about the right normal video signal. So obviously that just doesn't like going in there. Well, perhaps that 100 microfarad capacitor is just a bit too much. I think what I'm going to have to do is have a little play around off camera until I can get it to work. But basically I know we're in the right area, because I've done this before on a different model TV and it's worked fine. So I'm going to struggle on with this, but a bit pointless, so keep going. I'll explain it all when I'm finished. Right, well, I've been playing around with various different capacitors, and I found that a 1 microfarad capacitor seems to fit the bill. Unfortunately, one of the things that happens is that after it's been on a while, the picture fades, and so you have to adjust the contrast to stop it fading out. You probably can't see this on the camera. I can see that the camera seeing it as like a flicker. I may be able to sort of show it through there, but obviously it's not something I can screen grab. But what I found is if I add to ground a 10k resistor to that point there, it stabilizes it. So I'm going to make a little modification to the circuit. I'm going to put this capacitor and a resistor together. So effectively, if we go to the circuit diagram, I'll show you what I mean. So basically what I've done then is on here, I've cut this point here into the base, and I'm going to add into it a capacitor feeding the video signal, and I'm going to put a 10k resistor down to ground just to give it some stability, and that seems to be the right sort of thing. I've then got a phono socket, which I'm going to mount onto the back, and with some screen cable going around to it. So hopefully we'll get this into a state where I can show you that it's all put together nice and neatly. I may be able to mount the components on the other side because there's quite a bit of room on there, so I'll see what I can do. The collector of the transistor goes to ground, so I may be able to just put a bridge of the resistor between the base and the collector, and then just hang the capacitor off and take the screen wire off the top. So rather than doing it underneath the circuit, I'll take it on the top. So see what we can do. So it may take a little bit of fiddling around, but I'll show you what I've done when I've finished. So as luck would have it, I can mount the resistor quite easily between the collector and the base. But on the base there is also a solder pad which has not got anything connected to it, and there's nothing on the other side. So I'm actually going to drill a 1mm hole through that solder pad so I can feed the capacitor through into that to allow me to connect to that. So there we are. I've drilled the hole, fitted the capacitor through from the other side, got the resistor mounted, so that should all be good. It just cleans out a little bit of a cleanup, and we're good to go. So I've just got to mount the end of the screen lead to the capacitor, and also a ground at a point near there. So I'm going to need to find a component on the other side which is ground. So I think if I follow horizontally across where this one's connected, there's going to be a component just there that's going to be a ground. So I'll move over to that. Let's see if we can do that, so I can show you where the capacitor goes. Right. Okay. So there's the capacitor now coming through that hole, and we need to find a ground connection. So I'm going to keep hunting around until I find a good ground for the other side of the screen lead to go. So once I connected it with some heat shrink, that should all be nice and tidy. So I'll just go and find that and get it into position. Right, so there we are. We've got the capacitor hooked into the base hole that I made in there, and I've added an extra wire into a ground next to a capacitor here, which gives me the other side for that. So now all I've got to do is add a phono socket on the back of that and fix that onto the back of the set. So I'm just going to hook the phono socket onto here temporarily, because these phono sockets you have to put them into the socket, into the back of the, where they're going to fit into the chassis, etc., before you connect them up. They're not ones you can connect and then fit them, as it were. So I'm going to hook it in just to double check and make sure it's actually working before I finally drill holes in the cabinet. Right, there we are. We've wired it up, and I've got the phono socket there connected. So the next thing to check is to see that it actually works with my CCTV system. So I'll disconnect it from my signal generator, and I've got my CCTV connection there, and it's working. There it is, a nice view of my front driveway and the skip from the work that's been doing to get rid of my garage door. So all I've got to do now is put the socket onto the back of the cabinet, wrap it all up, find somewhere up there to stick it so I can use it. So hope you've enjoyed this little video in modifying a black and white TV to make it into a monitor, and it's pretty much a simple thing you can do on most TVs or portable TVs if they've got an isolated power supply like this one's got. So that's the important thing. So if you're planning to do something like this, make sure that the power supply is totally isolated. Usually you can say it is if it's got its own DC input socket, you know, for plugging in a mains adapter for something like using it in a caravan. So if you've got any old portable black and white TVs, or even colour ones, so long as it's got that isolated power supply, you should be able to do something similar to this. You just got to identify where the video is, split, so that you can put the video into there, and you're laughing, as long as it's working at 50 Hertz, of course. Anyway, thanks very much for watching. Take care. Cheerio.